previous video, the review video, we looked at fairly simple areas that were basically defined by, there was one function, and that was the upper function. And so if that function was called f of x, all we really had to do is the integral of f of x dx, from whatever this left bound is to whatever the right bound is. And when a function only has when a region only has one function that's really bounding it, these things are very, very simple. This lesson is about what happens when we have multiple functions that are bounding an area. And usually what that means is that in some way you're going to have to think about there being multiple regions, and therefore setting up multiple integrals. So we'll take a look at the first example that we have. The first problem type that I'm going to talk about is one where there are literally two clear regions. So in this case, we have this parabolic function, y equals x squared minus x minus 2, and I want the area of the green region. And as you can see, it's clearly broken into two different sections. But the good news is that it's sort of like, well, for this region here, it's bounded by the parabola, and for this region here, it's bounded by the parabola. I'm just going to have to separate this into two integrals because one of these is going to be counted as a negative integral, and the other is counted as a positive integral, and I want to make sure that I account for that. And so first, I should indicate, I suppose, using red, what would be wrong here. It would be wrong to say the integral from -1 to 3 of this function. And I want to make sure you guys think about why. Think about why doing that integral would not get you the area of the green region. If necessary, pause the video to do that. If you did that, what it would do is it would count this area as negative, this area as positive, and cancel them out. What that would give you is it would give you what's called a net area, where it's, how much is below and how much is above. But that's not what I'm interested in. What I want is actually the area of the green region. And so to do that, I'm going to need to set up two integrals. One of them I'm going to do between -1 and 2, x squared minus x minus 2 dx. And the other one, so the first one was from -1 to 2. The other would go from 2 to 3, right? So I'll sort of do this, and then I'll also do the integral from 2 to 3 of the same function. And it's worth thinking about what we expect about this. We expect this second integral to be positive, and I rather expect the first integral is going to be negative because the region is under the axis. So if I apply a negative to it, when the integral itself is negative, this second negative will make the whole thing positive. So again, I think it's good algebra practice, good basic calculus practice to do those two antiderivatives. So pause the video, work through those, at least work through the first one and see whether you get the right answer. So let's hear that first integral. We said it was going to be -1 to 2 of x squared minus x minus 2. So that'll be 1/3 x cubed minus 1/2 x squared minus 2x. You may have noticed that I got rid of the negative that was on the front of it. I'm just going to remember to do it later. So let's see, this goes from -1 to 2. When I plug things in here, I'm going to end up with 8/3 minus 2 minus 4 minus, and then plugging in -1, I'll end up with -1/3 minus 1/2 plus 2. Check and make sure I didn't make any mistakes there. That looks good. And now I can, start simplifying the stuff. I've got 8/3 minus 6. And then if I, distribute the negative through this thing, I'll have plus 1/3 plus 1/2 minus 2. And this is really nice. The 8/3 plus the 1/3 makes 9/3, which is 3. So I've got 3 minus 6 plus 1/2 minus 2. So let's see, that's -5 plus 1/2. So I'm looking at -9/2. And again, we expected that. We expected to get a negative number. And so when I make that positive to account for the area, I'm getting 9/2 for that region. right? I also need to look at this second integral. Fortunately, I've already done the integral part of it. I just need to plug in the 3 and the 2 this time. So I'm going to scroll down and do that. So for the other half of this thing, I'm looking at doing 1/3 x cubed minus a half x squared minus 2x, evaluated this time from 2 to 3. So plugging in the top bound 3 first, I'll get 9 minus 9 halves minus 6 minus 8/3 minus 2 minus 4. So again, we're sort of simplifying multiple things here. This will be 3 minus 9 halves. I'll distribute this negative through, minus 8/3 plus 2 plus 4. So let's start combining all this stuff together. I'm seeing the whole numbers 3 and 2 and 4 giving me 9 minus 9 halves minus 8/3. And if we're going to keep doing this by hand, then I've got to get a common denominator here, which will be looks like sixths, so that'll be 54 sixths minus 27 sixths minus 16 sixths. Just for reference, I don't usually have you guys do this much, arithmetic. 54 sixths minus, let's see here, that'll be 43 sixths. Yeah. And so this gives us 11 sixths. So that was for that portion. And so, for the final green area, we've got 9 halves plus 11 sixths. And we're this far, we might as well finish it out by getting a common denominator. 27 sixths plus 11 sixths gets me 38 sixths. So again, a lot more arithmetic than I think I was hoping for, but that's our sense of this one. When there are two areas, and again, we've seen this before, set up two separate integrals and work through them. It's really the last example that I think is something slightly different, so let's take a look at that one. So in this last region, it actually doesn't look like it's multiple regions. You're looking at this saying, oh, this is just one region. The question that I would ask is, if this is just one region, what are we going to take the integral of? Right? And what I hope you recognize, and it says there right at the top, the issue with this problem is that there are multiple upper functions. Right? This region has this function on top for part of it, and then this function on top for another part of it. So this first line function is the function y equals x plus 3, and the parabola function is the function y equals x minus 3 squared. I could tell that because this was just a basic parabola that had been shifted to the right by 3, so we put a minus 3 in there. And so the key here on this sort of the one new problem that we have in this lesson is that sometimes you've sort of got to set up, you sort of have to also almost imply multiple regions. What I'm going to do is say, this function x plus 3 is the top function, is the upper function, but that's only the upper function between -3 and 1. So it's almost like I'm saying the first region that I'm looking at is this one. Right? I'm going to be looking at the integral from -3 to 1 of x plus 3 dx. Then plus, I'm going to be looking at sort of a separate region between 1 and 3 over here where this thing stops. And for that part, since there's just, one function bounding it, I'm just going to do the integral from 1 to 3 of this one. So even though a function may look like it's only one region, if there are two different functions that are defining the upper bounds for those things, like the upper boundary, you're going to have to set up two integrals. So as before, I'm going to work through the arithmetic for this, and hopefully this one will be a little bit quicker than the other one was. This first integral is 1/2 x squared plus 3x, evaluated from -3 to 1. This other one, and I'm actually not going to FOIL this out, I'm just going to recognize that this thing is really like x squared. So I'll just do 1/3 x minus 3 cubed. And I'll have to evaluate that from 1 to 3. So let's see, this first integral is going to be 1/2 plus 3 minus 9/2 minus 9 plus, and the other integral, which I'll do in a different color so I don't get confused, this would be 1/3 times 0 cubed, that was plugging in 3, minus 1/3 times -2 cubed, that came from plugging in 1. While I've got the blue pen, I'll work out the second half of this. So this is 0 plus 8/3. And then for the other part, let's see here, I've got 1/2 plus 3 minus 9/2 plus 9. We can combine the two fractional parts and get -8/2, so that's -4 plus 12 plus the 8/3 we had from over here. So this is 8 plus 8/3. Unless you're getting a common denominator, you've got 24/3 plus 8/3, and our final answer is 32/3. So that's the end of this lesson. That's the end of what I needed to say here. The short of it is, you know, I'll redraw a picture of this thing here. If you've got a region that's sort of defined by multiple functions, and I mean, heck, you could even have sort of 3 functions that were happening here. If you had a region like this that you needed to work with, if you wanted to find the area of that region, you would need to do one integral with, one integral with this function as the top, between here and here. Then you would do another integral of this function between here and here. And then finally, you'd have to do an integral of this function on top between here and here. And again, generally, I'm not going to try and overload you with, oh, there's 5 top functions here. What we're looking at is just the concept that this can be done. I'm not sure if there's going to be a third video tonight. If there is, it'll be on the website and you can see it. See you later.